Mabuhay! Welcome to another video lesson on statistics and probability. Our topic is about illustrating the central limit theorem. Objectives. After going through this lesson, you are expected to illustrate the central limit theorem, define the sampling distribution of the sample mean using the central limit theorem, and create a histogram of the sampling distribution of the sample mean. Let us start by defining the central limit theorem. A central limit theorem is if random samples of size n are drawn from a population, then as the n or the sample size becomes larger, the sampling distribution of the sample mean approaches the normal distribution, regardless of the shape of the population distribution. Let us start illustrating a central limit theorem by answering this given activity. Activity 1. Consider a population of senior high school consisting of the values 1, 2, 3, 4, 5, and 6. Let us compute the following. 1. Population mean. 2. Population variance. 3. Population standard deviation. And 4. Let us illustrate the probability histogram of the sampling distribution of the sample means. In our activity number 1, the first question is to find for the population mean. We get the population mean using the formula population mean is equal to the summation of x divided by the population size. The symbols are the following. When we have the mu, this means that it is a population mean. This one is read as summation of x, meaning sum of all data in terms of x, and the capital letter N is the population size. Therefore, we have population mean is equal to the summation of x divided by the population size. We will now substitute our data. The populations are 1, 2, 3, 4, 5, 6. Adding all those together, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by the number of population. So as we know that it is from 1 up to 6, therefore, n is equal to 6. Now, adding all those together, we now have 21 over 6. And 21 divided by 6 is equal to 3.5. And this is now our population mean. Second question is to solve for the variance, the population variance. To solve for the population variance, subtract each data to the population mean and square the result. This table shows the summary of the difference between each data and the computed population mean in the second column, while the square of each is on the third column. Ito yun. While the fourth column shows the probability of each data. So for us to solve for the variance, we will be using the formula variance, population variance is equal to the summation of x minus the population mean to the second power divided by the population size. For us to come up with this, let us have it in a tabular form. First step, since we know that our x are the population, 1 to 6, the population size is 6 because counting all this together, 1, 2, 3, 4, 5, 6. That's why we have n is equal to 6. Next table, next column means x minus the population mean. A while ago in number 1, we solved for the population mean. and the population mean is equal to 3.5. Now, second column says x minus mean, therefore 1 minus 3.5, which is the population mean, the result is negative 2.5. 2 minus the population mean, 2 minus 3.5 is equal to negative 1.5. Next, 3. 3 minus 3.5 is equal to negative 0.5. 4. 4 minus 3.5 is 0.5. 5. 5 minus 3.5 is 1.5. And lastly, 6. 6 minus 3.5 is equal to 2.5. After that, all of these results will now be used on our third step. The third step is to square all the results we got from this second column. So negative 2.5 times negative 2.5 is equal to, so they are both negative. Lalagyan natin ng negative kasi ang sagot dito, negative 2.5. So negative 2.5 times negative 2.5 is 6.25. Negative 1.5 squared is the same as negative 1.5 times negative 1.5 is 2.25. Negative 0.5 squared is 0.25. Again, positive 0.5 squared is 0.25. 1.5 squared is 2.25. And 2.5 squared is 6.25. Adding this will give us 17.5, or the summation of x minus mu, or the population mean squared, is equal to 17.5. From there, we will now substitute the given 17.5 to this given formula. Since we now know that the summation of x minus the population mean squared is 17.5, we now have 17.5 divided by 6. And 17.5 divided by 6 is 2.92. So this is now the population variance. So, number 3, after mong makuha ang population variance, let us now get the population standard deviation. Ang formula niyan, as I always say, this is just the standard deviation is always the square root of the variance. So whatever we got from the variance, we just have to get its square root of, and we will now have the value of the population standard deviation. Now, on our fourth question is, we are asked to construct a probability histogram. And for us to do that, we'll be needing the probabilities of each population. As you can see, how many 1 do we have in the population? There is 1 over 6. Same with 2. Isa lang din yan. So, isa out of 6. Same with 3. 3 over 6. 4 is 1 over 6 also. 5 is 1 over 6 also. And 6 is also 1 over 6. A total of, when we add all the probabilities, its sum is 1. Now that we have the population and the probability itself, we may now proceed to constructing the probability histogram. In here, as you can see, since the probability histogram of the population wherein x is equal to x, and the population, the sample size is equal to 1, we have, sample size natin, isa lang. 6 things taken 1 at a time. Kasi ang population size natin ay 1, ang sample size natin ay 1 lang din. So, nung i-green up natin, ito yung 1, ito yung population natin, 1, 2, 3, 4, 5, 6. At ang probability nila ay 1 over 6, lahat. Kaya kung makikita mo at mapapansin mo, ang ating histogram ay pantay-pantay lang. Walang variation. So yan. Yan ang tatandaan nyo when we have x that is equal to x and when n is equals to 1. We will be having this one and we will compare it to the histogram of the second activity. Now, we now have the activity number 2. In here, we will still consider the population of 1, 2, 3, 4, 5, and 6. But this time, we will have samples coming from this having sample size of 2. So let us consider all the possible samples of size 2 that can be drawn with replacement from the population 1, 2, 3, 4, 5, and 6. Create a sampling distribution of the sample mean. Then after that, we have to compute for the following. Mean of the sampling distribution of the sample mean. Number 2, variance of the sampling distribution of the sample mean. Number 3, standard deviation of the sampling distribution of the sample mean. And number 4, let us illustrate the probability histogram. Kung napapansin nyo, yung hinahanap natin dito sa number 2 ay same doon sa hinanap natin sa activity number 1. And aside from that, we have the same population. Ang pagkakaiba lang dito, from this given population, kukuha tayo ng sample of size 2. And then, after nun, i-compare natin lahat ng makukuha natin na value ng mean, ng variance, ng standard deviation, pati na rin ang ating probability histogram. Okay. So, for us to construct a sampling distribution of the sample mean, of course, we will have to list down all the possible samples taken from the population with replacement. Yun ang sinasabi niya. So, listing down all the possible samples of size 2, alam natin na ang population natin ay 1, 2, 3, 4, 5, 6. So, inilista natin lahat ng samples of size 2 dito. So, paano maglista? With replacement. So, pwedeng maulit daw. So, starting from 1, 1, 1. That's why we have 1, 1 here. Then, followed by 1, 2, 1, 3, 1, 4. Ito siya. Ito yung mga sinasabi ko. 1, 3, 1, 4. Then, next, 1, 5. Next ay 1, 6. Ayun na. Tapos na siya sa 1. Ang next natin ay 2. So, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. Ayun. Ito sila. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And the next ay 3. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Tapos ka na ulit sa 3. 4 naman. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. You're done with 4. Then next is 5. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Next, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. At kung bibilangin mo lahat ng samples, ito ay equal sa n is equal to 36. Yan yung unang step, ilista lahat ng mga possible outcome. Ayan yung 36. Lista lahat ng possible outcome. Pag nalista mo na lahat ng possible samples, kuhanin mo ngayon ang mean ng bawat possible sample. Like, let's start with 1, 1. 1 plus 1, 2. Divided by 2, 1. 1 plus 2, 3. Divided by 2, it's 1.5. 1 plus 3, 4. Divided by 2, 2. 1 plus 4, 5 divided by 2, 2.5. So, ganun ang ganun parati ang proseso hanggang sa makarating tayo dito sa 4 plus 1, 5 divided by 2, 2.5 hanggang dito sa 6 plus 6, 12 divided by 2, kaya may 6. Ngayon, i-add na natin lahat ng sample mean. Ito yon. I-add na natin yan hanggang dito sa 6. Ang summation niyan ay 126. From there, makukuha na natin ang mean ng sample mean. And that is 126 divided by 36. Having that, 126 divided by 6, ang sagot pa rin yan ay 126 divided by 36, I should say. Ang sagot niyan ay 3.5. Pansinin nyo, kanina sa population, ang nakuha nating mean ay 3.5. Parehas sila, di ba? Kasi under the property of sampling distribution of the sample mean, kung ano man ang mean ng population, parehas ang mean niya, parehas din sa mean ng sampling distribution. Tatandaan yung property na yan, that the mean of the population is the same as the mean of the sampling distribution. Next, ito yung tanong sa number 1, ang sagot sa number 1. Next is to solve for the variance. For the variance itself, syempre may proseso na naman tayo since nakuha na natin yung 3.5. Sako na natin 3.5, ang gagawin na sa column na to, it's x minus the sample mean. So what we have now is from here, dito sa mga sample mean na, sa mga sample mean, minus, dito ka na, 1 minus 3.5, kaya nakuha ang negative 2.5. Kasi ito na yung magiging x natin eh. Ito na siya. So, 1.5 minus 3.5 ay negative 2. 2 minus negative 2 minus 3.5 ay negative 1.5. 2.5 minus 3.5 is negative 1. 3 minus 3.5 ay negative 0.5. So, gano'n ang proseso hanggang dito, hanggang sa 6. 6 minus 3.5 is 2.5. After nyan, after ng column na to, i-square na natin yung mga nakuha natin. Negative 2.5 times negative 2.5, 6.25. Negative 2 times negative 2, 4. Negative 1.5 times negative 1.5 ay 2.5. Hanggang dito ulit. 2.5 times 2.5 ay 6.25. Ganyan din siya dyan. Lahat ng to nakuha by squaring all of this. So, after nyan, itong column na to, i-add. That's why nakakuha ng the summation of x minus the mean of the sample mean is equal to 52.5. Okay, so after that, so as you can see here, we have the number 1, the mean of the sampling distribution of the sample mean, and we had already solved the value of the mean of the sampling distribution. This is equal to 3.5. I also reiterated that the population mean and the mean of the sampling distribution are the same. So in number 2, for us to be able to get for the variance, as we had the summations of x minus the mean of the sample mean square divided by the sample size, where n is the number of all possible samples of size 2. And as I have said a while ago, that our n is equal to 36. So, the variance of the sampling distribution of the sample mean is equal to 52.5 divided by 36, and that is equal to 1.46. Moving on, for the standard deviation of the sampling distribution of the sample mean, we have, of course, as I have said, this is just the square root of the variance. So what we're going to do is the square root of 52.6 divided by 36, and that is 1.21. To illustrate the probability histogram of the sampling distribution of the sample mean, the following table is needed. So we are now on the number 4, wherein we have to construct the probability histogram. And for us to do that, of course, we should have the frequencies and at the same time the probability. Because as we said, this is a probability histogram. Now, we have to list down all the sample means. Yung ginawa natin kanina, ililista natin isa-isa yung mga sample means nang hindi inuulit. So, we have 1, may 1.5. Kung babalikan natin kanina yung isang table na mahaba na kung saan nakalagay doon lahat ng mga possible samples mula 1 hanggang 36. Ito na yung mga sample mean. Inisa-isa na siya. So, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, at saka 6. So, ngayon, mula doon sa table na yon, bibilangan natin ilan ba yung mean na 1, ilan ang 1 sa mga sample mean. So, doon meron lang yung isa. Tapos bibilangin mo din ilan yung 1.5 na mean. So, merong dalawa. Bibilangin mo lang doon sa 1 to 36 kanina kung ilan ang 2, ilan ang 2.5, ilan ang 3, ilan ang 3.5, ilan ang 6. Tapos yun, kung ilan ang mga bilang nun, ito yung mga yon. Now, from these given frequencies, makukuha na natin ang probability. So, ilan ba yung 1 out of 36? Ang nakalagay dito, 1. So, the probability is 1 over 36. Ilan ang 1.5 out of 36? So, merong 2. So, the probability is 2 over 36. 3, 3 over 36, 4, 4 over 36, hanggang sa 1, 1 over 36. So, ang probability ng 6 ay 1 over 36. Ngayon na meron na tayong ganitong table, pwede na natin siyang ilapat sa probability histogram. So, eto na siya. Dito sa baba, yung mga means of the sampling distribution, eto yung 1, 1.5, 2, hanggang 6. Tapos, yung height nila ay yung probability. So, as you kasi kanina, yung 1, ang probability ng 1 ay 1 over 36. Ayan siya, yan ang height niya. Ang 1.5, ang probability niya ay 2 over 36. So, ayun. Ang 2, probability niya ay 3 over 36. 2.5, probability niya ay 4. Ang may pinakamataas o mas marami na exist kanina sa sample means ay yung 3.5. Ang probability nito ay 6 over 36. And so on. So, kaya papansinin nyo, kung papansinin nyo, ang graph nito ay normally distributed. Now, let us compare the values solved through the data in the population and the sampling distribution. Ito na. So, we have the population, yung activity number 1, at saka yung sampling distribution, yung activity number 2. Kinuha natin yung mean ng activity number 1, ang nakuha natin 35, at 3.5 I should say. Tapos ang sampling distribution din 3.5. Take note, the population mean is equal to 3.5 while the mean of the sampling distribution is also 3.5. Notice that the population mean is equal to the mean of the sampling distribution. That is, population mean is equal to the mean of the sampling distribution. Yan ay nakapaloob sa property ng sampling distribution of the sample means. Ang number 2, the population variance is 2.92. While the variance of the sampling distribution is 1.46. Notice that if we divide the population variance by the sample size of 2, kasi sa activity number 2, ang sample size natin ay 2 taken 2 at a time, we have 1.46 which equal to the variance of the sampling distribution of the sample mean. That is 2.92 divided by 2 is equal to 1.46. Therefore, meron tayong mas pinadaling formula that if we will find for the variance of the sampling distribution, all we have to do is to get the variance of the population divided by the sample size. So, yan. So, 2.92 divided by 2, makukuha na natin ang variance ng sampling distribution. Sa number 3, the population standard deviation is 1.71. While the standard deviation of the sampling distribution is 1.21. Notice that if we divide the population standard deviation by the square root of the sample size of 2, we have 1.21 which is equal to the standard deviation of the sampling distribution. Kaya nga yung 1.71 divided by the square root of 2, ang sagot 1.21. Kaya panibagong formula ulit, kung mas madali, kung hinihingi ang standard deviation ng sampling distribution, ang gagawin na lang natin kung may given tayo ng population standard deviation is to get the population standard deviation divided by the sample size. So, yan. Yan ang pagkakaiba ng dalawa. Bukod pa doon, may difference din ang kanilang probability histogram. Dito, sa unang activity natin, the probability histogram of the population wherein N is equal to 1 looks like this. Ayan, kung titingnan nyo, kasi pare-pareho yung probability nila 1/6. Kaya definitely, pantay-pantay ang graph ng bawat isa, yung bawat population. While, nung kumuha tayo ng sample mula sa population, taken 2 at a time, kung mapapansin nyo, ang nangyari, naging normally distributed. The illustration is more likely to have a curve of a normal distribution, while the probability histogram of the population is not normally distributed. Ito, not normally distributed. Based on our activity, it was evident in the central limit theorem that the sampling distribution will be approximately normally distributed for a large sample regardless of the distribution from which we are sampling. Also, it is important to recall that the mean of the sampling distribution of the sample mean is equal to the population mean. And the standard deviation of the sampling distribution of the sample mean having sampling with replacement is equal to the standard deviation over the square root of the sample size. discussed previously, if the population is normally distributed, the sampling distribution of the sample mean is also normally distributed. But what if the population is not normal? That is where central limit theorem address this question. The distribution of the sample mean tends towards the normal distribution as the sample size increases. Kaya naman kung titingnan nyo kanina, sa activity number 1, ang M lang ay 1. Nung sa activity number 2 na, ang N natin ay equal sa 2. So, kung papansinin nyo, dinoble natin yung sample size ng activity 1, ginawa nating 2, naging normally distributed na. Diyan pumapasok si central limit theorem. Basta lang, sabi niya dito, as the sample size increases regardless of the distribution from which we are sampling. At the same time, as a simple guideline, the sample mean can be considered approximately normally distributed if the sample size is at least 30 or N is greater than or equal to 30. Kaya naman kanina, mula sa population na 6, kumuha tayo ng sample, taken 2 at a time, ang nakuha nating possible sample ay 36, wherein pasok na dito sa definition ni central limit theorem, that the sample mean can be considered approximately normally distributed if the sample size is at least 30. Ang N natin 36 eh. Kaya, kung mapapansin nyo sa probability histogram natin, yung graph natin ay normally distributed na. Yun, doon pumapasok si central limit theorem. Other than that, if the sample size is sufficiently large, the central limit theorem can be used to answer the sample mean in the same manner that a normal distribution can be used to answer questions about individual samples. This also means that even if the population is not normally distributed, or if we don't know if its distribution, the central limit theorem allows us to conclude that the distribution of the sample mean will be normal if the sample size is sufficiently large. It is generally accepted that a sample size of at least 30 is large enough to conclude that the central limit theorem will ensure a normal distribution in the sampling process regardless of the distribution of the original population. Further, we can continue to use the Z conversion formula in our calculations. This time, we will use the given formula. Z is equal to the sample mean minus the population mean divided by the standard deviation over the square root of the sample size. So take note of that. So even if it is not being mentioned, if it's a distribution, for as long as the sample mean is, or the sample size is sufficiently large, and well, we can consider it as normally distributed for as long as the central limit exists and the sample size is at least 30. Why is it important to know the central limit theorem? Bakit nga ba? So many statisticians have distributions that are approximately normal for large sample sizes. Even if we are sampling from a distribution that is not normal. This means that we can develop statistical inference procedures that are based on normal distribution. Even if we are sampling from a population that is not normal, provided we have a large sample, provided that we have a large sample. So let us illustrate through this example. Suppose that the average age of the people living in a barangay is 34 with a standard deviation of 4 if 100 residents of a certain barangay decided to take a summer outing after the COVID-19 pandemic and enhanced community quarantine has been lifted for bonding and relaxation. What is the probability that the average age of these residents is less than 35? Solution. So, as we have, it is not given in the population, it is not given that the population is normally distributed. Walang binabanggit. But, since n is greater than 30, the sample size is greater than 30, then you can assume that the sampling distribution of the mean ages of 100 barangay residents is normal according to central limit theorem. So dun po mapasok si central limit theorem. Yun yung isang bagay na pwede natin i-consider, although hindi naman niya binabanggit if it is normally distributed, kasi usually babanggitin yung data is normally distributed, blah blah blah, and so on. Eh, ang problem natin, hindi niya binanggit. But since the number or the sample size is given that is equal to 100, from there, using the concept of central limit theorem, we can say that the mean ages of 100 barangay residents is normally distributed. With that, the central limit theorem describes the normality of the distribution of the sample mean taken from a population that is not normally distributed. Step number 1. Let us write all the given. Population mean is 34, nandito siya. The average age, ito siya. Standard deviation of 4. And then, we have here 35. So, the average age of this residence is less than 35. Ito yon. So, ito magiging sample mean natin. And then, our sample size is 100. Kasi 100 residents ang kinuha mula sa population. For us to know, we will convert it to Z para malaman natin ang value ng Z, tapos makuha natin ang Z value mula sa Z table. Yun ang importansya ni central limit theorem. Pag alam natin na it is normally distributed, then I can use the normal distribution table, the standard normal distribution table or the Z table itself. So, we will convert it using this formula. So, substitute lang natin yan. So, we have the sample mean is 35 minus the population mean is 34 divided by standard deviation 4 over the square root of the sample size, which is 100. So, we have 35 minus 34 is 1. 1 over, yan ay 1 over 4 over 10. So, yan. Kaya to naging 10 over 4 kasi we know that 1 is a whole number, so its denominator is 1. The denominator is 4 over 10, so we'll get the reciprocal of that, and then we will change the operation to multiplication. So this will be 10 over 4. And then, meron na tayong 10 over 4. Kaya meron ditong 10 over 4. 10 over 4 or 10 divided by 4 is 2.5. Ang Z natin ngayon ay 2.5. Take note, ang sabi niya dito ay less than 35. So, meaning that is Z less than 2.5. So, step 3, use the Z table to find the probability of Z less than 2.5. Ito na. So, ang 2.5 ay 2.5 at saka 0. So, ito siya at saka ito. Recall natin yung paggamit ng C-table. Intersection lang yan. So, ang area nun, ang probability nun ay 0.4938. And then, after nyan, since less than siya, kung idodraw ko yan, ang 2.5 mo ay nasa kanan ng mean. 1, 2, this is 3. 2.5 is here. Since that's less than, kung less than yan, ibig sabihin, papunta siya sa left. Ang nakuha kong 4.938 ay mula sa gitna, papunta sa 2.5. Ito yon. Ang nakuha kong value ay mula dito hanggang dito. Yan. Ito yung, para lagi nyong natatandaan na, ang value mula sa z-table ay mula lagi dun sa mean, papunta dun sa value ng z. So, this is 0.4938. Ang kailangan ko, mula dito sa 2.5, papunta sa kanan. Papunta sa kaliwa pala. Papunta sa kaliwa itong lahat. Since ang kabila ay shaded na buong buo, and we know from the fact that this region is equal to 0.5,000, therefore we just add these two. That's why ang probability ng z less than 2.5 ay 0.9938. Therefore, the probability that a random sample of 100% has an average of fewer than 35 years is 0.9938 or 99.38%. So that ends our discussion. Our reference is the Statistics and Probability, the Pivot Copy. Thank you for watching. And if you are new with my channel, don't forget to like and subscribe. This is Juliet B. Goodbye.